In this video we are going to talk about tangents and chords in circles. So tangent is a line that touches the circle from one point, and regardless of the tangent drawn, you can draw infinitely many tangents, but whatever you draw as tangent, you can always draw a radius which is perpendicular to a tangent. So when you have a tangent line, you can draw a radius meeting at the same point, and that radius is always perpendicular to the tangent. So this angle is 90 degrees. As you can see in this figure, from one point you can draw two tangents to a circle, which makes it more interesting because when you join the center with that point, when you join the center with that point, well, consider it joined, you have two triangles where this tangent line have the same size. We know that this is the radius, so these are the same, and this is the common hypotenuse, because these are right triangles now, right? This is the common hypotenuse, so it's the same length in both triangles too. So you get two congruent right triangles here. So when you have a right triangle, you should immediately remember Pythagoras and trigonometric ratios, of course. This means there may be questions asking the side lengths of these triangles, right? This hypotenuse or the tangent bit or the radius bit, or an angle may be given. You could use simple trigonometric ratios to find one of the side lengths once the other is given. Or you may have two sides given and you may be asked to find the angle here or here. And there may be other combinations when you are asked to find an angle. There could be other combinations of circle theorems related to it. Now let's see some examples. The diagram shows a circle center O. PT is a tangent to the circle. Find the value of x. Now, the crucial information you should know that just because PT is a tangent to the circle, this angle is 90 degrees. Once you know this angle is 90 degrees and you know this angle, it's just basic angles in a triangle question. So it's gonna be like 90 plus 48, which makes 138 degrees, and 180 minus 138 will give you 42 degrees. Hence, x equals 42 degrees. This question could be in two parts. In part A, asking for the angle y here. Let's say they would ask this angle, so find. It's just because they would ask you the reason of this angle being a right angle. So you should say tangent to a circle is perpendicular to the radius. That's it. Let's look at this example. Now here it says PT is a tangent to the circle with center O. So there are two information here. One, PT's tangent, right? Two, center is O. If center is O, then OP is the radius. This means we have this radius and tangent meeting at the same point P, which makes this angle a 90-degree angle. So we have a right triangle here if you consider this completed as a line here. Right. OT is a line segment, so we're talking about this line now. OT is a line segment that cuts the circle at R. So this also tells us another thing. O, R, and T are on the same line. So this is a line. This is not a broken line. This is a complete line. So this is the hypotenuse, basically, of this right triangle. Right. So PT is given, which is 12. So let's write here, this is 12 centimeters. OP is given as 5 centimeters, so that's gonna be 5, not 7, 5. And we're asked to find the value of RT only, not the hypotenuse, not the whole hypotenuse, not this one, but only RT. Well, that's okay, because we know this bit is radius, so it's also 5. So I'm going to find the whole hypotenuse, OT, and then take away 5. So in a circle context, it is quite hidden, but when you have a closer look, when you think through it, it's not that hard. You're going to find the hypotenuse from Pythagoras and take away the radius. So what happens is OT squared is 5 squared plus 12 squared, which is 25 plus 144, which ends up with 169 as a sum. So OT would be the square root of 169. Sorry, I did 136, I guess. It's 169. So the square root of 169 is 13. So OT is 13 centimeters, this bit altogether. So I know that this is the radius, so it's 5. For RT, it's going to be 13 minus 5, 8 centimeters. Right, so go to exercise 17.1 in your textbook. It's on page 322, extending towards 323 and 324. Do the questions 1 to 4 and 7. Please solve them and check your answers in the online self-check. Thank you.